Good morning, guys. Welcome to day 2 of calculus. Today's going to focus upon slopes, linear equations, basic stuff from algebra. This is one of the more frustrating parts of calculus is how much we use this information. And so it's far enough back that many of you guys may have forgotten some of the finer details and may need some updated practice on it. And so for us, we're going to be doing this with our calculus class. It's going to feel like an algebra class today. It's going to feel like an algebra 1 class today. The reason being is, of course, that if you don't know this, moving forward in my class is virtually impossible. And because of that, we need to make sure every person has a good understanding of how to develop a linear equation, how to use a linear equation to create a graph, and how to determine things like parallel and perpendicular, which we might have to save for tomorrow. We ran out of time. Before I continue, I did not make it clear last time, and I need to make it clear, and I will say so in the instructions as well. All assignments for this class will be turned in at any point in time. However, they are due Friday at noon. The reason for this is because we only do Zoom sessions twice a week, on Tuesdays and Thursdays. And so I don't want to have Monday's assignment due Tuesday, but be due before a Zoom session. And I don't want to have Tuesdays due Wednesday, but you missed the Zoom session because of some reason. That'd be awful. I do a 1 week or 1 day a week due date so that people can turn their stuff in and get it all done and make sure that they should have opportunities to go to various Zoom sessions if they wish to. Now, if for some reason you cannot make that date, we can discuss and send emails back and forth about alternatives. But I usually have a deadline of 1 day a week. I will accept all homework. It is due that day. If you're done on Monday with Monday's assignment, turn it in. You're done. Don't wait. But it is due on Friday at noon. Okay? So let's get to it. For today, we're going to be talking about those linear equations as we suggested, and here we go. All right. First thing to remember about us is because you're in calculus, you're going to start seeing some alternatives. As we mentioned before, calculus takes a lot of previous topics and expands upon them and develops them further. One of these ideas is the idea of change. Now, you may have seen this symbol before. The delta is a Greek letter. It is the fourth Greek letter. Alpha, beta, gamma, and delta are the first four. And this Greek letter, and it is used to indicate change. Now, some people always ask, why delta? Well, first, D is often confused with 6. If you've ever been a sloppy handwriting like I am, D and 6 can start to look very similar if you're not careful. And so you have to notice those kinds of things. And so D is the main reason why we use delta, but why do we use D at all? Like, that doesn't make any sense. Well, you have to remember the first change anybody talks about in mathematics is change on a number line. And so if I want to talk about the change between a value of 1 and a value of 5, we talk about that change, that delta, as being 4. Because it's how much my number has changed from 1 to 5. And it's also how much my number has changed from 5 to 1. We call it the change delta because this is the distance. Distance and change are intertwined. So if we talk about distance and the number line as our change, then that's why we use delta, because delta is D, which stands for distance. And so when we talk about change, it's always going to be with the Greek letter delta. Now, the most common change you're probably used to talking about is rate of change. This is a term that should have been covered a lot in your Algebra 1 class, but it's probably more better known by its other term, slope. Slope, by its definition, is the rate of change of a linear function. So slope, in its definition, assumes you're talking about something that is linear. And it's talking about how that linear function is changing. Now, there is a way to calculate it. In fact, I'm going to write down 2 ways to calculate it. Both are very similar. In fact, both are the exact same. It's just various ways of writing them. The first way is probably the way you learned how to write it whenever you were in, algebra class. So I'm going to write S for slope, or as more commonly, M is used for slope. So M is equal to, you probably learned it as y2 minus y1 over x2 minus x1. Now, this is great, but this is not the calculus way to write this statement. The way you write this statement in calculus is, this is the change in y divided by the change in x. And that makes sense up here, because if we think of this as an x-axis, 4 is how much it takes to get from 1 to 5, but it's almost also how much it takes to get from 5 to 1, just in different directions. And so y2 minus y1, if we take these as y values, 5 minus 1 would give me 4. It makes sense that that's a delta. And if this was an x-axis, the same deal happens. And so delta y over delta x is the calculus way to write slope, because your how much y value is changing is y2 minus y1. How much the x value is changing is x2 minus x1. So here, if I want to determine delta x, I just take the second x value minus the first x value and do 5 minus 1, which is why my delta was 4. And so this is how we define slope in calculus. It's different than algebra. I'm not quite sure why algebra teachers don't do it this way. Possibly because, algebra students, they aren't that smart. At least not yet. They're not calculus students yet. And so we assume now that you're smart, you're calculus kids, you should be able to know that these two are essentially the same thing and that they have the same meaning. And you might have also learned by one other way, rise or run. But this actually makes a lot more sense with the delta y and delta x, because how much you rise is how much your y value is changing. Because it's how much you rise or go up and down over time, your y value change, divided by your run, which is how much your x value is changing. And so rise over run, delta y over delta x, y2 minus y1 over x2 minus x1, all three of these are the exact same thing. They're just representative of slope. And the first thing you need to be able to do is be able to calculate slope. Now, I'm not going to go through a lot of examples of this. I'll go through one here in a moment. But before I do that, let's define slope in a more traditional sense. There are 4 ways to talk about slope, depending on how it's interacting with the graph. We determine a slope is positive to be considered to be increasing from left to right. If a slope is negative, we consider it to be decreasing from left to right. If the slope is 0, we consider it to be no change from left to right. And if the slope is undefined, we consider this to be no left to right movement. We think about it this way because this helps to solidify the delta y and the delta x. If you consider the following picture, in order to determine how a line is acting, all we have to do is ask, what is it doing from left to right? Well, here on the left-hand side, it is down lower than on the right-hand side. So over time, as we move from left to right, it is going up. That would mean that this function is increasing. We would say this has a slope that is bigger than 0. Compare that to a function like this one. Again, as we move left to right, this function is going down over time. So we say its slope is less than 0. Because over time it goes down. There are 2 others, which we've already mentioned. So let's take a look at those. Let's see, we got my positive here in red. We got my negative here in blue. Let's do orange. Orange does not show up super well, so we'll do our best. It means that there's no change from left to right, meaning it isn't going up over time and it isn't going down over time, but it is still going left to right. What does that look like? Well, I have to make it a little more bold so it sticks out. This is when my slope is equal to 0. So, my slope is equal to 0 because there is no change from left to right. As I am moving across the page from left to right, I am not going up over time, I am not going down over time, I am staying the same. And so we consider this to be no change. Or, more oftenly, we call it a 0 slope because there is no change. Now, last of these, which are here in purple, is considered one where there's no left to right movement. Well, if the graph can't move left to right, it can only move one other way. up or down. And we'd say this one is a slope that is undefined. This may... it's not very well up and down, is it, Douglas? Jeez, how awful are you at drawing? Very, very awful. Beautiful. That is just beautiful. Do that again. Okay. So these are the four possibilities. Either the graph over time is tending upwards from left to right, so we call that an increasing function, an increasing line. Or, for the blue one, it's going down from left to right, so we refer to that as decreasing. The orange one has no change, so we consider that a slope of 0, because 0 is the thing between positive and negative. It makes sense. And then the one that isn't going up and down, or the one that isn't going left and right at all, is considered to be undefined because it's not following the rules. So notice how we define all three of these by the same process. What's happening from left to right? Is it going up? Is it going down? Is it not changing at all? Now, this is how we define a line. And because of this, we can use it to make certain predictions about how a point or collection of points will look on the page. So let's talk about how to find slope. So for this, I'm going to make up 2 points. Let's say the point 3, 4, and the point 5, -1. Okay. The question is, how do we find the slope? And then afterwards, we're going to interpret the slope. When I look at the slope, does it mean that the function is increasing? Does it mean that it is decreasing? Does it mean there is no change? Does it mean that there's undefined change? So, increasing, decreasing, no change, and undefined. So, all we have to do to figure this out is plug into here. Now, usually whenever I have these kinds of problems put up here, people ask the standard Algebra 1 question, which is, where's x1, where's y1, where's x2, where's y2? Now, this is my first point. So I consider this value to be my x1, and this value to be my y1. I consider this value to be my x2, and this value to be my y2, because this is my second point. This is the x value of the second point. This is the y value of the second point. This is the x value of the first point. This is the y value of the first point. But as it turns out, it doesn't matter which way you do it, because you'll get the same answer. So I'm only going to do this once, because for many of you this will be too basic. So let's do it. I do y2 minus y1 over x2 minus x1. And then I simplify using order of operations. -1 minus 4 would be -5. 5 minus 3 would be 2. And this is considered to be my slope. Now, because the slope is negative overall, this would tell me that this is a decreasing function, or a decreasing line. The slope is negative. Note, we declared this to be x1 and y1, we declared this to be x2 and y2. If we had done it the other way, we would have gotten the exact same result. If we had chosen this one to be y2, which would make it 4 minus a -1 over 3 minus 5, what will end up happening is on top you'll get a positive, on bottom you'll get a negative. But guess what? These two are equivalent to each other. It's a property of negatives that doesn't matter whether the negative in a fraction is on top, on bottom, or outside. All three of them are the same, which means that the order of these isn't really important. It just means you have to be consistent. Whatever y value you put first, put its x value first. So if I want to make -1 come first, that means 5 has to come first. If I want to make 4 come first, I need to make sure 3 comes first. Consistency. Notice that the top number is just how much the y value is changing. My y value is 4, and it's changing to a -1. To go from 4 to -1, I have to change by a value of 5. And since it is going down, it's -5. On the other hand, my x value is how much the x value is changing. So from 5 to 3 is a distance of 2. So you can see how my delta y would be -5, my delta x would be 2, And when you divide those, you get that answer. And if you do it the other way, you get the same result, just with slightly different delta y and delta x. But when you plug it all in, the answer checks out. That's the point of slope. And again, the point of all mathematics is that we should agree upon what the answer is. So this is the first piece of your homework, of being able to do basic stuff like being able to find slope. But let's look at the second part, something that you guys may not have done in a little while. And for these ones, let's remind ourselves of some things. Lines. When it comes to line, there are a few basic ways to talk about a line. The first way is called general form, or sometimes called standard form. Kind of depends on who you talk to, which version this is. I'm going to put the book version that I use, ax plus by plus c equals 0. And in this case, a and b cannot be 0. This is the general form of a line. Now, there are some exceptions to this. You have something called the vertical form of a line, where if a line specifically is vertical, it will always have the form x equals a, where in this case, a is the value on the x-axis the line goes through. Remember, since this is supposed to be a vertical line, like this one here in purple, if I look at this line in purple, it would have the equation x equals a number. But what number? Well, it'd be whatever number on the x-axis we cross. So I see here we have a -2 on the x-axis where this line goes through. So that would mean that this equation would be x equals -2, because it's where we cross the axis, the x-axis. You also have the equation for a horizontal line, which is y equals, I'm going to give it a little b, and this b is a value on the y-axis the line goes through. So we look over here, this orange line was considered to be horizontal because it's going just left to right. So vertical lines, by definition, have undefined slopes. Horizontal lines, by definition, have slopes of 0. So let's talk about this orange line. We would say this orange line has an equation of y equals 1 because it is a horizontal line. So it always have y equals b as our equation. But what's b? B is the value on the y-axis the line goes through. Well, where does it go through the y-axis? Right there. So we'd say this is y equals 1. Whereas this one, we would say is x equals -2. For much the same reason. Because it's the value on the x-axis that it goes through. So, there are two other ones. These are the more common ones that you're probably more familiar with. You have point slope, and of course, slope intercept. Now, point slope is the fancy one. Y minus y1 equals m x minus x1. And then slope intercept is y equals mx plus b, where again, b has that exact same property, where it's the place the line crosses through the y-axis. So, these are our basic equations of a line, and always have been. What this means is that whenever we talk about a line, we can use the equation to talk about the line, we can use the line to talk about the equation, and they all fit together. In other words, I can use this information to determine the equation of a line, I can use the equation of a line to determine the graph, I can use the graph to determine what kind of line it is. And they all fit together. So, if I have a picture that has a horizontal line, I can use the picture to get the equation, and the equation has to match the properties. And so all three of those pieces, the picture, the type, and the equation, all have to fit. Now, to let you know, v most common equation you will use in calculus is this. That is crazy if you ask me, because it's an Algebra 1 equation. And yet, you will use this in your calculus classes next year hundreds of times. Not even an exaggeration. Hundreds of times. You should learn this equation if you haven't already. The other couple are like nice, like this one's useful sometimes. This one is rarely useful. These ones not great, but they're there, they exist. This one is this one's the best for calculus. Because a lot of calculus revolves around slopes and points, as weird as that sounds. So, for many of the problems today, I'm going to ask you to use that equation. And so let's take a look at an example for today and discuss kind of how we can determine when you use these equations. So, you'll be asked throughout your problems today to do a couple of basic ones, like finding an equation. Now, when you find the equation, unlike some teachers, I am fine with any of these 5. However, I consider the best one to be this one to start with, and this one to finish with. Like I said, I'll say it one more time. This is the best one to start with in general, and this is the best one to end with in general. That does not mean that there will not be times in this class where I will start with this one and finish with this one. That does not mean there will be time in this class where I will start with this one and finish with this one. There will be time in this class where I start with this one and stay there. Like, there's no rules. Like, I can't tell you what to do on every single problem because any of these could be applied. What you have to understand is, when it comes to calculus, you're given formulas and said, solve a problem. You have to figure, how to use that information to get the equation, or to get the information we need. So, let's talk about the following equation. Let's say I have an equation of a line with a slope of 3 and a point of 1, -2. If I'm asked to find the equation of a line, the best way to do that is to start here. To start at this equation and say, okay, let's plug in the information. Now, as a reminder, the slope is just m. This value is my x value, because it's the x of my first point I am given, and this is the y value of the point I am given. So if I wish to use that equation, I'd have to do y minus my y value of the point, which is -2, m, 3, x minus the x value of the point, which is 1. This is considered to be an acceptable answer, and I will star it. However, this is not typically the answer we typically want. Instead, it is simply best to simplify this kind of equation and to get to a better answer. So let's take a couple of simplifications that I can do. I can distribute to negative, so double negative would make this a positive. I can distribute to 3 to get 3x minus 3. And then I'm going to go ahead and switch it to the other form to get y equals 3x minus 5. This is also an acceptable answer. In fact, all 3 of these are acceptable answers. However, in general, this bottom answer is the one that I want. That is because it is considered to be the agreed upon answer in algebra, and calculus kind of has to follow algebra rules. Notice that this equation, we plugged in the best starting equation and found our points from there. Why do I consider it the best? Because it's the most versatile. Let's look at another example. In this example, we have the point 4, -1, and the point 2, -4. Now, when I'm given 2 points, none of these equations work very well, except the fourth, point-slope form. Now, it doesn't work right now, because in order to use point-slope form, I need a point, which I actually have. I actually have 2, but I also need the slope, which I don't have. Thankfully, because I have 2 points, though, the slope is equal to that equation, delta y over delta x. And so I can determine the slope easily and thereby find both pieces and get our solution. Notice this bottom one is still a good equation, but it requires two things. I need the slope and the intercept. Neither of these is the slope, neither of these is the intercept. And so using this version is better. Now, as is common in algebra, you are asked to take those steps to go and get to a solution. So let's do that. From here, I'm going to find the equation of a line. First thing I'm going to do, find slope. Slope is delta y over delta x, or the algebra version, y2 minus y1 over x2 minus x1. From here, I simplify. Double negative and negative is positive. Negative 4 plus 1 would be negative 3. 2 minus 4 would be negative 2. And double negative makes that positive, so I'd have 3/2. And remember, what order you do it in doesn't matter, but that's my slope. Now that I've got the slope, I can plug into that form. Y minus y1. Now, in order to use this equation, remember you need a point and the slope. It does not specify which point, so I can choose either one. I'm going to choose the first one. Why? Because I can. Because I can. It doesn't matter which one you choose, as long as you choose one of them. I'm going to do 3/2 x minus 4. And then this is considered an acceptable answer, because it is the equation of a line. However, we are going to simplify. You'll find that in calculus, a significant portion of the extra time that you may take is usually done via simplifying stuff. And I'll move the 1 over, end up with y equals 3/2 x minus 7. There it is, the equation of a line. And remember, when it comes to the equation of a line, the slope tells you how much it will rise over run. So in this example, I can tell, because of how it is written, that I will be rising 3 for every run of 2 that I do. So over time, the slope is positive. That tells me that with a positive slope, it'll increase or go up from left to right. So as I'm going across, it will look more like this red line here. Not exactly the same, but pretty close. It will go up over time. It may go up by a steeper amount or a less steep amount, but it is going up. And it may cross down here, or it may cross up there, but it is going to go up over time because that's what the slope is doing. Notice the intercept has that other part of the question. Where does it cross? It says it crosses at -7, so it's going to be down here, and it's going to be going up over time. Again, from left to right. This is a good place to pause. We'll continue with talking about lines, sketching lines, and the last piece, which is parallel and perpendicular. That'll be what we do on Thursday. But this will be your next assignment. You'll be asked to do things like find the slope, and you'll be asked to do things like interpret the slope. You'll also be asked to find the equation of a line. And for these ones, since this is so basic, I am going through it very quickly. If you have problems with it, please let me know when we have our Zoom session tomorrow, which I look forward to. Until then, I will see you guys later.